It is my great pleasure to introduce Louis-Philippe Morency. I hope I said it correctly. Yeah. So, Louis-Philippe has the honor to have been born on a farm with 300 sheep.
I did.
That's what makes him special. He's from Canada, from Quebec, which is the capital of Quebec City, the capital of the province of Quebec. And he did a PhD at MIT in robotics, actually. And then since then, he has been working at USC's Information Institute for Creative Technologies, which is half Hollywoodish type things and half computer science. They try to create these big sort of displays of animations of humans and things. And you can talk to them, they talk back to you, there's dialogue inside there, they do discourse, they do all kinds of interesting things. And they look at your gaze, they look at your hand gestures, they look at your sentiment. So they try to embody all the modern things that we do in NLP into these agents to make them act properly. This is both to train army personnel, so that we could put army personnel in these simulated environments, give them a difficult situation and see what they do. But you can also see some of the results in like the Boston Science Museum, where you can talk to the sergeant and he talks back to you and he can tell you stuff. And it's kind of like an Eliza, but a little bit better. So in that context, there's of course all kinds of opportunities for interesting research in all aspects: speech recognition, vision, visual recognition of what people are doing when they speak, when their hands move, when their bodies move, when their gaze is, in terms of sentiment recognition, in terms of dialogue, and ongoing dialogues, and how you manage all that stuff. And Louis-Philippe is in the middle of this kind of research. So he talks to people who do robotics, and he tells them how to make robots work with us. And he talks to people who do HCII. And he talks to machine learning, he does this a lot. And he talks to us as language people. He publishes in all these conferences all the time. He wins all kinds of prizes. Most recently, he heard that he got a UNESCO award. And so in March, he's going to go wherever the hell it is. They're going to give him some award, right? I'd like to give you the secret.
Thank you. So if there's any reporters, please don't tell it, but in end of March, we will be presenting one of our projects at UNESCO, but the official release of the information is on Wednesday. So thank you very much for the introduction. And yeah, my name is Louis-Philippe Morency. I became LP in the US, but you pronounce it perfectly, so wonderful. And I'm here to talk about machine learning and human communication. How can we bring all these together and be able to create really interactive computers or really interactive technology? And as you expect, this is a large of this group. It's a group of my students working on this project at ICT. And what I would like to start with is this great example for the few people who've seen that before. Don't tell others. But it's really to exemplify the importance of verbal and nonverbal. And so I'd like you to look at this dialogue. We love dialogue here. So we have a dialogue, simple dialogue, interviewee. We have an interviewer saying music online. Guy Cuny is the editor of technology website News Wireless. Hello, good morning, good morning. Were you surprised by the verdict? I'm very surprised to see the verdict to come to me because I was not expecting that. When I came, they told me something else. I'm coming. They told me something else. Big surprise. I on purpose tried to. I'm already loud, so yes. I probably don't even need the microphone. 1, 2, 1, 2. Test. Better? I probably don't need it. So what's interesting here, I on purpose didn't put any prosody or the emotional in the voice, but just from that, I'm asking you, as good student in computational linguistic, to try to infer some of the dialogue act or some of the intent behind this. Specifically, I'm interested at his behavior, at his answer, and try to infer what is he trying to communicate through this. And so he's definitely surprised of the verdict, possibly. That's probably one of the inference. He's not expecting that, so he's not expecting the verdict, most likely. So it's interesting, but let's try to add one more modality. We're going to push the multimodal here, and so hopefully the audio is not too loud.
Of music online. Well, Guy Cuny is the editor of the technology website News Wireless. Hello, good morning to you.
Good morning.
Were you surprised by this verdict today?
I'm very surprised to see this verdict to come on me, because I was not expecting that. When I came, they told me something else, and I'm coming. You got an interview there, so it's a very big surprise anyway.
A big surprise.
Exactly.
Yes, yeah.
Okay, so I just added one more channel of information, and we can see a big hesitation here to cut this verdict on me. So we have definitely a long pause filler, add a little bit more, and a smaller group I will be asking people what do you infer. But now we're going to go to the next layer, and definitely we got a little bit more information, probably that the surprise may or may not be on the verdict or maybe on me. So now we're trying to get more of this information. I'm going to add one more modality, the visual modality, and now look at both his facial expression, body posture, and try to infer really what his internal state or intent communicating.
Of music online. Well, Guy Cuny is the editor of the technology website News Wireless. Hello, good morning to you.
Good morning.
Were you surprised by this verdict today?
I'm very surprised to see this verdict to come on me, because I was not expecting that. When I came, they told me something else, and I'm coming. You got an interview there, so it's a very big surprise anyway.
A big surprise.
Exactly.
Yes, yeah. With regards to the cost that's involved, do you think now?
So what did you infer? Now we have multimodal information. So where's the surprise in this case? Oh. How many students do you need to get an answer? What's the surprise?
It's surprised that the subject is me. Why does come out me, not somebody else?
There's definitely me. And at the beginning, we have experts in facial expression here, you definitely saw a lot of surprise in his name at some point in the beginning, so I'm going to bring back. So when did the facial expression happen? I'll have to point to Jeff. So he definitely put a lot of a surprise expression at this moment of Guy Cuny. So did anyone infer what happened? What is it that exactly happened? So
it's the wrong person.
So his name is Guy Cuny. Oh, so we got that, right. But he is not the technology website chief. He is a cab driver. And he went to the airport and saw his name on the airport sign. He followed the person all the way to it's in England, all the way to the TV show, and went through all the makeup and everything, and only at that point did he end up having. So definitely you could not have inferred everything, but you could see that the facial expression helped identify some of the key problems, and also help inferring also more of the dialogue intent in this. So this is a funny, entertaining example, but I think this is true for many applications. Being able to infer both the verbal and the non-verbal messages allows us to be able to improve technologies, like being able to recognize distress in a person. We also can push it even further with teenagers and be able to predict suicide attempt or suicide reattempt. We can also look at autism, that definitely has been one of the aspects of improving nonverbal communication. And with this aspect of medical, I think is so exciting, bringing all this technology there. But there's also 3 other lines of research, which one of them is also really important here, being in an educative setting. We definitely want to be able to recognize this behavior to help students better working together, better improving. And that's definitely seen in rapport, and you see it in how people work together. We're pushing that, a close collaboration here with CMU on being virtual learning peer. And even recently, we've created an audience, a virtual audience. You guys, so attentive. And be able to improve public speaking. People who knows about Toastmaster. It's a Toastmaster with a virtual human. But in all of these cases, we want to be able to infer from these information about the social signals, like leadership, empathy. And you want to be able to look also online these days. There's a wonderful source of information. One of them is being YouTube. And yes, my students are watching a lot of YouTube. A lot of it maybe for their own purpose, but then some of it is for work. And part of it is for sentiment analysis, And also persuasion. What makes someone extremely persuasive? Some video has no influence, some of them have a lot of influence. Why do you get that? Can you quantify this? And so persuasion, and one aspect also is negotiation. Can you predict the outcome of a negotiation before the end of it? And that would be one of the more business-oriented. In all of these cases, we want to be able to recognize, we're able to predict the subtle communicative behaviors. And really, at the end of this, what you get is be able to, I think at the core of it, is be able to model human communication dynamics. So my talk today will be a lot around this 4-dimension of human communication dynamics. Because if you want to be able to infer from it, I believe you need to model the behavioral dynamics, the multimodal dynamic, the interpersonal dynamic, and in the broader sense, the societal or cultural dynamics. I think this is a long-term research agenda, but there's already wonderful work that's been started, and I'm giving you the path to that direction. But just so you understand, what do I mean by all these dimensions? Let's start with behavioral dynamics. What do I mean is the same behavior, the same smile, the same word, like the word yeah, can have really different meaning depending on the intonation. I call it 50 Shades of Yeah. For people in speech, and mostly people who've been in Japan, I want to be able to recognize who it is you're hearing. He's a really well-known speech researcher. But in a 1-hour meeting, he said the word yeah about 120 times. And they definitely could not associate the same dialogue meaning to each of them. So let's listen on a few of them, and you tell me who it is for the few people. Stuff for him. But so Nick Campbell, yeah. So this is Nick Campbell at one of our meetings. It's a great example. We've cut all of his. And this smile. Nick. And also this is true with smiles. We want to be able to, same smile, you have a polite smile, the dynamic of a smile. So each of this, when you want to look at this as a future research direction, there's a lot of challenges there. You want to be able to understand the subtle dynamic of it. And in the wild, not just in the lab. You want to be able to also model this special temporal, because really what's differentiate the yeah from one to another is a lot of how it is spoken over time, how the pitch varies over time. In the case of a smile, how you drop the smile, the offset. And really, the same smile may be interpreted by different people differently. Cultural difference comes in it. So you have to think about it when you approach this part. The second part, which I think becomes obvious from the example I gave you earlier, is the multimodal dynamic. Speech and gestures have a dynamic, has a synchrony. I'm doing a lot of beat gesture right now, on purpose probably. But this comes and synchronized with the verbal, what you say, how you phrase it, but also the prosody of it. So how you emphasize certain aspect of what you're saying, how your voice change over time. And coming also a lot from the nonverbal, it ended up having a full column for the nonverbal. But definitely a lot of it is the gesture you're doing, the body posture you're showing. I have this great example that I'm using often about proxemics, which I believe is really interesting and quite culturally specific. We have a wonderful new student that comes from China. At USC, we have quite a few students from Asia. And so I explained to him something on the whiteboard, and I turned and he's right there. And that was my Canadian bubble was popped completely. But definitely that was something really interesting. We had a wonderful conversation after that about culture and proxemics. With virtual human, you lose some of that. With robots, you're still really important. You have a shared space. Eye contact extremely important when you give a talk, also when you're listening to a talk. And definitely facial expression are really important. And also, as anybody who's been working on this topic knows, this is more than the 6 basic emotion. We're going on further than just happiness, surprise, and all the. We want to go like to confusion, understanding, and look at them as one smile or one gesture doesn't mean there's only one emotion. There's really a distribution over that. So doing this kind of fusion really brings new challenges for machine learning. How do you synchronize or handle this asynchrony? How can you be able to handle this different type of gestures? Some of them are symbolic, some of them more as a signal. You also have the problem that modalities sometimes complement each other, or in fact, they can be opposite. Sarcasm is an example of that. And the output of them, you want to be able to predict all of them in a more cohesive way where each of them can help. So this brings really interesting machine learning problem. And I think one has been understudied but really identified as a core problem is the social aspect, the interpersonal aspect. And here's I have this wonderful video from a student I've been collaborating on with for 6 years. And we were wondering, just working on the simplest thing, listening feedback. And we were like, there must be a recipe for listening feedback. Like there's certain type of handouts for continuation, some for acknowledgement, some for agreement. There must be that. And then he went back home and he tricked his friends, not friend, but people. He had one speaker and 3 listeners. And they all believe that they are the only listener. And we like to believe that we are the only one, so that was easy to trick them. So they all seeing the same person, they all believe that they are having a dyadic interaction, one-on-one, but he only sees one of them. Your task is going to be, during this video, to tell me who of these 3 people he is seeing. And that goes at the core of communication. But at the same time, I want you to look at these 3 people and look at the variability from person to person in this nonverbal behavior and looking at how everybody has a different range. So please, and it's in Dutch, so we're going to put aside verbal for a second. And maybe a few people can handle, but focus on the nonverbal for this one.
De regenpijp omhoog klom naar het raam waar de kooi van Tweety stond. Het tweede was dat hij door de regenpijp kroop, maar dat het Tweety door, dus gooide Tweety een bowlingbal in de regenpijp. Die raakte Sylvester en dan kwam die onderaan de regenpijp eruit. En die had hij dan ingeslikt, die bowlingbal, dus hij rolde door de straat in het bowlingcentrum. En natuurlijk een struik of zo, in ieder geval het geluid van omvallende ketels.
So I stop here. He does talk about bowling ball, that we got that. He speaks Dutch. Okay. So what is he really? A bowling ball?
Yeah.
Okay.
We've got Tweety and Sylvester, an episode from the
Yeah, so exactly. So they use a lot of the same classic David McNeil's bowling. They show Twitter and he's retelling the story. So, okay. So in all of the you guys, the audience, who believes that the speakers, the person he sees is him? Who thinks that it's him? Okay. Okay. Right. Who thinks that it's him? Okay. Go fewer. Okay. 5, 6. Okay. And who thinks it's him? Okay, thank you. 3, 4. Okay, so for people who voted him, why? What's going to point? Why did you? One of the reasons, just one reason. They smile at the same time. Yes, he's definitely smiling and interacting a lot more, reacting a lot more. And who voted for him? Yes. You see the synchrony between the two very much, and here's, I put you on the spot, Ed.
I thought the synchrony was both, and so for the other 2 I thought it couldn't be them, so it had to be the guy who was almost not reactive.
Not reactive because I want to trick you guys. Exactly, the answer is him. He is the one, and if you look closely, it's about the chair. It's the motion of the chair. He starts the motion of the chair. He follows the chair. In fact, he ended up moving his chair. So they indirectly, by association, end up interacting together. And so very much so, he's definitely giving more feedback, more engaged. It turned out at the end of the video, he ended up more engaged. But that doesn't tell you that who has the full interaction. The full interaction really happened in this case. What was interesting also is the difference between people, okay? And that's what we found. We were sure that small handouts will mean like consideration, slightly larger will mean acknowledgement, and agreement would be the big one. Really what it turned out is there's a lot of idiosyncrasy. Everybody has their range, and a lot of it end up being like, at the end is, yes, this person, if you look at the whole video, he has his own way of doing a continuation handout, but it's his own way. And for him, it ended up being maybe the equivalent of an acknowledgement handout. So what you look at the analysis, you really have to look... Is you really have to look at it as interpersonal dynamic, but really looking at how individuals are behaving. When you look at interpersonal, you want to be able to model the entrainment or the rapport between the people. And really, at the end of the day, we'd love to create these predictive models. How can I predict someone's reaction? And eventually build this jointly. So this brings really a lot of new challenge in machine learning and computational modeling. And the final one, which I think has been really understudied in computer science, but definitely studied very much before. Yes?
The fact that majority of the people in this room chose the wrong answer.
Yeah.
Doesn't it somehow hinder your research and what you can do? I mean, when humans themselves can't find out what's happening, how can you aim for a computer to understand what's going to happen?
So I picked a video, and I picked a video that effectively showed stronger listening behaviors for this guy. So a lot of people associate the listening behavior as the full dyadic interaction. What it tells me is that there is a need for different kind of classes to really explain the human communication dynamic and really being forward. I see it as a wonderful example of people's intuition being not exact, or at least not complete. If you had a lot more time to analyze this video, I think a lot of you come back also to the same, I hope, to the same conclusion. I gave you really short time, I partially tricked you, but I think I mostly used your intuition, which was in this case wrong, which is that someone who is smiling more probably is the one who has the full interaction. So I see it as a great example of computers being able to be objective in this case and be able to give information without that subjective aspect. So I think it's exciting in that sense. So hopefully it doesn't stop us from giving that research. And you will see some of the results which are really exciting on building real virtual human engaging using that technology. So I think it's a really good example moving forward. So thank you. And any more questions? I love questions. That's what makes it fun. Otherwise I was just talking to myself. So that's really, if you have more questions, please ask anytime. A strong, really important aspect is the cultural differences. As you would expect, I already talked about proxemics. I have also a cultural difference between European and Americans. Definitely really big. But really at the end of this, we have really looking at group dynamics, looking at how people are interacting together, how people are adapting to new culture. You meet someone for the first time, and so you're adapting to them, you're adapting your dynamic, you're adapting their behavior, you're inferring for that. But really at the end of the day, I can tell you, not all French Canadians are like me, or it's probably a good thing. So you have also to put the individual in it, so personalities in too. So it brings, at the end of the day, a lot of wonderful research topics. The modeling, the behavioral, multimodal, interpersonal, and cultural dynamics. It brings together two fields that were talking to each other really few, like human communication study, learning how people are communicating verbally and non-verbally. And that means that from a machine learning perspective, it allows new type of interaction, new type of studies, because now we have new tools from machine learning that allows human communication studies on a larger scale. But the other way, the fact that we're studying human communication brings topics that were understudied in machine learning. And that allows us to create new computational models. And I think in general, this really brings closer this gap of behavioral and AI back together. And I think one of the community that's been pushing that forward is the multimodal interaction community, bringing these two fields together. And we see it more and more in larger scale conferences and specifically in ICMI. So today what I will do is first give you an example, because now I've told you what the problem is. Let me give you a concrete example of a project we've been working on for 2.5 years. That's the one that will be presented at UNESCO. And so the project is the DCAPS project, Detection and Computational Analysis of Psychological Signals. I will use it to show you how we can bring all these dynamics together, and then I will talk about the specific of the algorithms we're using for that. But first, we built a system over the years to be able to infer from a user, from a patient, to be able to help the clinician in an interaction. So the idea is that you will want to be able to quantify nonverbal behavior while the patient is interacting with the clinician. So you have a clinician-patient interaction either through the web or we love virtual human, so you can also have an interaction with a virtual human. So the person is interacting with a clinician or a virtual human. During this interaction, we are automatically analyzing all of their verbal and nonverbal behaviors and creating a report. That report can go back to the clinician that help deciding on what the medication goes or how to go forward with the therapy, or help also with the diagnosis. So the idea here is that one of the ideas is to automatically recognize these indicators of depression. And key to that, this is a decision support tool, it's not a decision-making tool. So this is just about informing the clinician, giving more information. We're not making the information. I would not want a computer to make that decision, but I definitely want a computer that helps. Virtual humans are wonderful for many things. Virtual humans, if you tell them to do something, they do it. And if you tell them to do it over and over, they do it. So if you're looking at the responses of a patient, you want the stimuli to be the same. So you compare apples with apples, oranges with oranges. So having a virtual human allows us to have the same questions as exactly the same way. We can vary it if we want, but in our case, it's a great advantage, it's consistency. A second aspect is virtual humans are working over and over, so they are definitely more scalable in some sense. But I think the best advantage is this replicability and consistency of virtual human. So at the end, what we get from this approach is some indicators that tells you how that quantify how this person behaved today. And then you compare with last week, with 2 weeks ago. You can even compare with a reference population that tells you how distressed and non-distressed people were. And then you can even put it in a more summarized way where you compare different indicators and help the person, the therapist to see how the person behaved. And one of the wonderful preliminary results we've seen is that depressed people, if you ask them, or if you have an analysis of them, a lot of times they will still feel depressed. But then you talk to their wife or their siblings, and they will say, oh, he's smiling more, he's interacting more. And then suddenly they're like, and a lot of times this could be predictive of recovery. And we had a long discussion today about this, but so this is a nice, interesting first finding that will be great to quantify. So at the end of the day, what we do is a lot of what clinicians do every day, but be able to quantify it numerically. So now I will use your brain, ask you to look at this interaction, looks at the nonverbal behaviors, and try to identify indicators of distress, specifically nonverbal for this example. What I also want you to look is not just the patient side, but also the clinician. Because clinicians good clinician will create gesture, will create an environment that's really show a lot of empathy. And if we want to create a virtual interviewer, we want to look at both sides. So please look at it for indicators of distress.
And when you think about that instinct that is really the question is, how strong of a reaction did you see ever felt that kind of heat and pressure when I'm in this area.
So
I mean, I noticed it.
but maybe not everybody else noticed it.
Yeah, I mean, I don't, I didn't need a medic to come rescue me or anything, but.
So what does she do? What behavior or gesture do you see that could be, yes?
Her hands are really tense.
They really are very much. Huh? Then you connect one, maybe able to give us some of it. Really tense and then shaky a little bit, yes. Any other, yes? She's definitely closing herself very much. She's moving back and forth. Any other? So, but you see that slowly she's building empathy and rapport. At the end, they have a mirror or a common smile. So that you can see this. Maybe she's will open up. So we've done an analysis up to now with more than 167 face-to-face interaction. Oh, here is a virtual human 101. How to build your own virtual human. First step. Analyze face-to-face interaction. Second step, Wizard of Oz. So we build the first version of the virtual human based on the dialogue, but put the human behind the curtain to be able to animate, and then build the AI system. This is nothing new for a lot of people building dialogue system, but this is how we built this in this case. So 167 face-to-face interaction. Our goal is to look at indicators of distress. We also look at more than, at this point, we have almost like 600 interactions. This is like 250 hours of videos, one of the largest in this case, and we're looking at indicators of distress. So, what do you believe the indicators of distress are? First one, really not surprising. If I ask you what are the top one, people who are distressed show less joy and more sadness. It didn't surprise you here, huh? The really interesting one is looking down. People are, in fact, looking down more often, and that goes on often with their posture. Really interesting, that has been done also before, is the number of smile was exactly the same, or almost exactly the same. That was surprising for distress and non-distress, but the smile was shorter and less amplitude, and that was interesting. People show more self-adapter, also sometimes called self-touch, although self-adapter is more politically correct. And so you see a lot in anxiety, and you see a lot in the PTSD, and specifically on the face for PTSD, which is really interesting. The legs fidgeting, the voice was really interesting. It's not just that some people are loud or some people are soft. That doesn't tell you on distress. It's the range of it that really gives you the information. And the voice quality, the tenseness of the voice also gives you some of the information. So now we were looking at even go deeper into this analysis and try to look at difference between men and women. So looking at head rotation, this was something that was true for men and women, that you see less of these interaction. What's interesting is when you look at emotion variation. That's interesting because you see less in both cases, but there's a small gender effect where women in general just have more variability in emotions. So that maybe go with our intuition. The most interesting one was we knew that there would be something related with eyebrows or facial expression, negative expression. We expected that. But then we looked for a while and we could not find any difference. For distress or non-distress, there was no difference. But then we split it men and women, and wonderfully what we saw is the opposite trend. And that was really interesting. And I think one of the most interesting results is that people who are depressed, the women, are showing less, in this case, frowning, and this is true for other negative emotions, so they show less of them, but the men are showing more. And this is also true for disgust in this case. Our hypothesis is that, and this was maybe just an LA thing, Los Angeles thing, but women are expected to be more poppy or happy, and maybe men are allowed to be showing more of these negative emotions. And we definitely see this in this case. Yes?
Yeah, a version of that is that the woman knows she's distressed, and so she's masking for it.
I think so. I think it's related to the masking. That's our hypothesis. We need to do more research to really confirm that. But this was a wonderful result, and that's because of this kind of technology we're able to go there. What is interesting is that we're also able to look at specific, because we have a virtual human she's asking always the same question, so you can see how are people responding to specific questions. And in this case, tell me about the last time you felt really happy. And the content is really important, but in this case we look at nonverbal, and time to response was a big one, and definitely the balance, and so how much positive or negative words. So sentiment analysis, which is well studied in NLP, has a really big importance also in this kind of situation. We went a step further, and this is one of the projects I find really important. It's a suicide ideation, or being able to recognize suicidal ideation from non-suicidal ideation. In this case, teenagers, more than 40 teenagers a week go to the emergency room with suicidal ideation in Cincinnati. I don't know in Pittsburgh, but and LA, no, I don't know either. And this is also the third most important cause of death in teenagers from 11 to 17, way too young. So can you help there? Can you look at that? And then we look at the first version of that, and effectively the same kind of voice changes that we saw for distress also generalized for suicide. Now we're doing a large-scale study with 300 patients and also looking at these differences for nonverbal and verbal. So I think that would be really interesting. Putting everything together and building a virtual human. This is a video that we put on about a few months ago that really puts everything together, where you will see on one side the sensing and on the other side the virtual human. The virtual human is fully automatic. There is no human behind the curtain in this version. And please look carefully at both sides, because I think this is one of the big achievements for us. Yeah.
Hi, I'm Ellie. Thanks for coming in today. I was created to talk to people in a safe and secure environment. I'm not a therapist, but I'm here to learn about people and would love to learn about you. I'll ask a few questions to get us started. And please feel free to tell me anything. Your answers are totally confidential. Are you okay with this?
I know. That's the most.
So, how are you doing today?
I'm doing well.
That's good. Where are you from originally?
I'm from Los Angeles.
Oh, I'm from LA myself. When was the last time you felt really happy?
When was the last time? I don't know. Yeah. I'm not someone who's really like, I don't have any real highs. I feel like I'm a level person. It's just happy. I guess to answer your question, probably a couple months ago.
I noticed you were hesitant on that one. Would you say you are generally a happy person?
I'm generally happy. It's just lately there are things just keeping me down.
Can you tell me more about that? When was the last time you felt really happy?
I try to stay happy. I'd rather be happy. My kids keep me going.
What advice would you have given yourself 10 or 20 years ago?
I'm going to stop here. What you see is a real-time analysis of the speech, of the voice, of the facial expression, body posture, gaze, all this integrated in real time, inferring some indicators of distress. In this case, we looked at fidgeting of body activity, also at gaze pattern. we infer from that change in the state of the user. This is taken into the dialogue in real time, and then the nonverbal behavior of the virtual human are adjusted, and the verbal response also in real time. So this is a big, large effort, but I think it's exemplified the idea of the importance of behavioral dynamics being modalized here, the multimodal aspect, and very much the interpersonal. We saw also the nobody laughed at that one, but the back channel is really important, and we recorded about 150 This was the wrong one, definitely, and I think it's in itself a small but really important research problem. Another really important research problem is turn-taking. Is really important. In this case, I didn't tell you, but this is a push-to-talk version of the system. Now, if you come to ICT, the new version has free speech, so no push-to-talk, and that's, as we know really well, is a big challenge, but it works almost the same as the push-to-talk in this case. So really a lot of challenges building this interactive, but a great potential of really having an impact. And so one of the questions we had is, should we build this system? Why are we building them? Why not just keeping this with any human interaction? And one is the consistency of the virtual human, but some people just love talking to their dog, or just love talking to some other person or non-person. And so we did this experiment where we had 77 people interacting with the exact same system. Okay? In this case was the Wizard of Oz version, and we've done it with the AI, but exactly the same system, but we just frame it differently. For half of them, we tell them, you will be interacting with a human behind the curtain. Or half of them, we tell them it's a fully AI system. There's nobody watching the interaction. So, and the interesting finding is when you ask them afterward, evaluation, their fear of evaluation is much lower when they interacted with the AI system. The other interesting thing is their impression management is much lower when interacting with full AI. Even more, if you quantify automatically their level of facial expression sadness, they just show significantly more with the AI system. So now we have another reason, possibly, to build this system, not just the consistency, but also building the system because people are just displaying more of them. They're just less managing their own expression. So I want to give you how now, the fun part, the machine learning, and how we make it work, because this is really bringing a lot of new research problems, and so I'd like to show some of it, and I will emphasize mostly on the first three, behavioral, multimodal, and interpersonal. So on the behavioral side, we want to build, as I mentioned, some more robust, fine-grained, and temporal models of this. So how do you do this kind of sensing? Why is this problem so important and so interesting now? Is that you get new technology from sensing. Part of it is commercial, and part of it is also new technologies here at ICT and outside to be able to look at sensing of facial expression, of the voice quality in real time. We in fact developed, and you're free to use, all of these are available for free, but the latest one which we built is a brand new facial landmark detector that we compared. On this data set, we compared with state-of-the-art and gave really good performance. So now we have all this low-level sensing, and in fact we integrated all of it in Multisense, which we show live. One of the things when you build this, and you spend all this time on the algorithms, but if you really want to have an impact, you have to be able to share that information with people. So we spend a lot of time developing a perception markup language so that this perception can be shared with the dialogue manager, with the virtual human or the robots. And so we develop a perception markup language that has multiple layers of representation. The first two are the most obvious, sensing and behavior, which are, a lot of it, the behavior layer is similar to the behavior markup language. But then the third layer, which is more the intent, is still under development because we need feedback on that one. But this is great because you get in real-time output of all this information. But really at the core, we want to be able to model in real time this link between the low-level sensing and the gesture. So how do you do this? And sorry for this slide, I mean, you guys know all of this already, but I put it just as a placeholder. But to bring this, there's a lot of work on generative model and on discriminative model. Generative versus discriminative 101. Generative really look at each gesture and try to understand how to generate or create that, while the discriminative model really look at how to differentiate the two class labels. So you have many examples of naive-based generative model, or the equivalent of, you can see some energy-based model like maximum entropy model for discriminative. And there's been extension to be able to model either first-order chains like HMM and CIF. One of the great things of the HMM is being able to learn this hidden dynamic. And I believe strongly that when you analyze this gesture and you want to understand the behavior, you need to be able to learn this. And so conditional random field, that is a discriminative model, but wonderful for being able to recognize, but unfortunately doesn't model this latent dynamic. In our case, what would be an example of latent dynamic? Would be an example in a gesture. So if I am waving, there's a sub-part. I'm extending, I'm waving, and I come back. There's a sub-gesture. This is also true in language. There's a structure to the phrase. So this is why we've been building over the years new extensions of these conditional random fields. So we built the hidden conditional random field and the latent dynamic conditional random field. The idea there is to be able to not just model the relationship between your sequence of input feature, but also being able to learn this latent substructure. And so to give a clear example for this audience, I created this example from shadow passing or non-phrase segmentation, and where the idea here is to be able, from a sequence or a sentence, to be able to label the start of every non-phrase. This is a well-studied problem, but just to give you an example, I want you to understand what I mean by this latent structure. What we've done at this point is train on this kind of problem, train LDCIF, latent dynamic conditional random field, where you model the relationship between words and these non-phrase labels using this latent variable. And you do this by modeling the conditional probability, looking at probability of your while sequence given your observation. What's really great with the latent dynamic conditional random field is that it makes assumption, it has a subset of latent variable or latent state for each labels. That allows it to be, in fact, really efficient in the inference. It allows almost as fast inference as the CIF, but it adds to it the latent variable. It's wonderful for a real-time system, but in our case, what I'm most interested in is to find out what do this model learn here? What is it learned? If you look just at this layer on this example, you can look from your data and look at the most likely hidden state for each of these labels. Given a label, what are the most likely hidden states? And start looking at what were the words associated with it. And what you find out is for any specific observation, you get a most likely hidden state. What's interesting is when you look at that and start looking at the mapping between words and frequency, you end up learning that the LDCIF learn automatically the part of speech tags. So what this ended up being is the LDCIF, we never gave to the algorithm the part of speech tag. We only gave it the NP labels and the words, but implicitly the model learned that structure, that implicit structure that you have in your label, and automatically learned, in the case of B-tree, that these words are more likely, and if you look at the part of speech, these kind of part of speech tag are more likely, and you see it for a lot of examples, and that also gives state-of-the-art performance for part of speech tagging. So this is true for recognition of syntax, analysis of the syntax, but it's also true for gesture. We can use the exact same model for gesture. Now, the hard problem is to go a step further. We have verbal and nonverbal, and we want to fuse this information together. How do we get data? YouTube is a wonderful source of data. People love talking about themselves, love talking, giving their opinions. So finding data is the easiest part in our case, and also what's really nice of YouTube is a lot of it's automatically transcribed. So you end up getting transcription for all of it with data. So how do you learn the mapping? In our case, let's say we want to do sentiment analysis, but multimodal sentiment analysis. We want to be able, from the YouTube video, be able to infer something like a positive or negative sentiment in the video. What's really interesting is to look at what are the top features that comes down from this kind of analysis. The first one is smile. Not too surprising. Smile is correlated with positive, so that's really not surprising. Looking at the camera is in fact really important. What's interesting is the visual in this case helps really well differentiating positive from either neutral or negative, but doesn't help between the two. If you do a pause length, if you look at the pause length of the vocal aspect, you can see that the pause length, people who are showing neutral or like more objective statement are in fact showing more longer pause. And their voice level is also lower. So that's really interesting, and it helps really well to differentiate between objective and subjective. And the words are really important. But as we know, the words can be sparse in certain situations. In this kind of situation, we have like shorter sequence. How do you able to handle, even for short utterance, to be able to estimate the sentiment? So in this case, doing the multimodal will help strongly. We've done it at the utterance level, so being able to infer sentiment at the utterance level, and we can see really well that just, I think the baseline here is just how many of this utterance are positive, negative, or neutral, and so we can see that the majority vote, and each modality, and as you add the modality, you can significantly improve the performance. What's interesting is you can also do it at the video level, and in fact you got the same kind of result. And the reason for that is that we only use SVM in this case, where we didn't model the nice temporal sequence, as I will show you in the next slide, but you get similar improvement from multimodal. And we can also show it for Spanish, which is really interesting. The same kind of features, in this case, also work for Spanish and English video, which was really interesting. So how do we do this kind of modeling? We, in fact, realized that before going into the math, which is usually the fun part, we wanted to go a step further, because my understanding is that if we are to do multimodal processing, we need to go further than the typical NLP problem. So sentiment analysis has been well studied, but if you're going to do multimodal, you have to think a little bit outside the box. And so multimodal is great, and what we learned is the following. If you do multimodal sentiment analysis, and your only goal is to recognize positive from negative, I will highly suggest to simply look at the word. But what adds the nonverbal allows you to see how strongly do I like something, how strongly do I hate something. This is where the multimodal comes in. Also, another really interesting is persuasion. The multimodal really helps when you analyze persuasion. So this video, you want to look at nonverbal behaviors. You want to know what makes a video really persuasive. So we did a study first with 3 hypotheses. One first hypothesis is what is the relative importance of every modality. And as we've done, the second one is to find out what is the speaker trait of someone really persuasive. And finally, what's the speaker trait, like passionate, maybe, compassionate, or attractive. Our first hypothesis was attractive was really important, and our results are really interesting. And what are the personality traits associated with persuasion? So the first aspect, which is maybe not so surprising, effectively, as you add modalities, you see an increase in how reliable humans are estimating persuasion. What's really more interesting is to look at the speaker trait. What are the most strongest speaker traits? Confidence, passionate, and entertaining. Attractiveness is not even higher than the significance level. That's really interesting in our case. our hypothesis in this case was completely wrong. Or maybe it's just the data, so we have to do more experiment. And personality, you have to be conscientious looking, and definitely if you're too neurotic, you're not going to be a good persuader. That's what we found from our data. So how do we infer this automatically with machine learning? What is the multimodal fusion 101? Early fusion versus late fusion. I mean, this is where you need to start. Definitely early versus late fusion is the basic. Early fusion is great for this automatic, simple synchrony between modalities. Late fusion loses this automatic synchrony, but allows for decision levels recognition. This effectively works in certain cases, but I will say we need to go further than that. What really is interesting in multimodal fusion is to start to see how one modality helps the other modality. How is the modality can help? How can you co-train from one modality to another? That, I think, is core to a lot of these problems. And we can see that by doing co-training, in this case, to be able to recognize agreement or even doing speech recognition, you can be able to improve speech recognition in certain cases by improving with multimodality. And also, if you're recognizing agreement, you can also improve by looking at gestures, where each of the modalities are helping each other. We've been building algorithms to improve on that. So I talk about latent conditional random field, but a lot of the challenge is that your modalities have a non-linear mapping between the two of them. So you want to be able to take advantage of recent progress in neural network to be able to learn this non-linearity between your modalities. And this is how we've been creating the latent dynamic conditional neural field that really takes advantage of learning the substructure of your label at the same time as you're learning the non-linearity between your input features. Another really interesting extension of that is the idea of multi-view learning, where you're learning the synchrony between one stream of information and then the second stream of information, and learn how are they synchronized over time. And that can be done both over a segmented data, meaning that you have a whole video and you're estimating only one label, or you can do it over unsegmented data where you are estimating the label over the whole period of time. This improves strongly the recognition in multiple data sets. We have done it on arm gesture, but more recently looking at debate and agreement between people. This is really interesting, and one of the really interesting framework we've been pushing is going further than just classification and looking into regression. I gave you the example of depression. We don't want a decision making. We don't want to make, is it depressed or not? We would like to give more of a continuous value that the clinician can look at. So we've been pushing further for continuous conditional neural field that takes the advantage of conditional random field but do it in a regression framework, learning at the same time using the neural layer in this kind of energy-based model. What's really interesting of this model is by making assumption that making the multivariate Gaussian distribution assumption, we can efficiently infer from that by simply looking at the mean of this Gaussian. So inference in this case becomes really efficient, and you can do that over even long-range dependency, which has been a big problem with conditional random field, while in this case of the continuous conditional random field, you can put long-range dependencies without any problem. And this framework, although we use it first to look at emotion recognition, or also in the action unit recognition, it outperforms many of the state-of-the-art. We also apply the same framework for facial landmark detection. So we can use it not just for 1D chain, but we can easily do inference on a 2D grid using the exact same framework. These are examples of all this new field, which I find really exciting, of multimodal machine learning, that has a lot of challenges, some of them understudied in typical machine learning, looking at multi-stream learning, looking at multi-output learning, also looking at how different heterogeneous feature representation can be put together, and really looking at each label. If I show you the same video clip, you may end up interpreting it differently than your neighbor. So this interpretation, changes in interpretation, has also to be taken into consideration. Also, the same smile can mean more than one thing. There's not just one label. You may end up as a distribution over the labels. And that also is another example of aspect of multimodal machine learning that we need to push forward. All of the work that I presented is part of the open source dataset library that's called the HCI library. So the last and interesting part is the interpersonal dynamic. I think it's been understudied. It's been studied in psychology and sociology, but not as much in computer science. And so we see a lot of work on social signal processing, or sometimes called behavioral computer science. The idea is, let's try to model the interaction between people and be able to model this. So maybe we create a robot or a virtual human or a dialogue system, or just being able to infer how well people are working together. And an example of that is students working together. How do you infer if students are working well together? And I believe that a big part of it is about rapport and seeing how people are, collaborate, are in fact in training each other and connecting to each other. And you can see this as in simple signals like voice. Are they mirroring the same voice patterns from one person to another? Are they converging or are they diverging? And that's really interesting because just looking at this, we can predict, by looking at students working together, we can predict if people, looking at simply the voice and looking at when this voice is correlated or not, we can predict the moment of high synchrony and also the moment of low asynchrony. And these, a lot of time, correlate with bad answers. Bad answers in this scenario was 3 people working together, having homework with 10, 15 questions, and being able to answer these questions working together. We see a correlation in this case of asynchrony. What's really interesting is also to go a step further and find in a group who is the leader and who is the knowledgeable person. And what I mean by that is the loudest is not always the smartest. I'm quite loud, so hopefully, yeah. But it's not. But the idea is, how can you differentiate leadership from expertise? Because if you have a group of people, you want to be able to find the expert from the leader, or maybe they're the same. Hopefully, in certain cases, they're the same. But really, putting expertise and leadership and trying to differentiate that is a great example of looking at interpersonal dynamic. One of the models that we've built over the years is being able to look at empathy and looking at listener back-channel feedback. You saw the example with Ellie and the SimSensei system. What we do in this case is use the same kind of machine learning algorithm, conditional random field or LDCIF, to be able to learn from the speaker when would be a good time for the listener to give a back-channel. So, I'm going to teach you guys when is a good time for you guys to give me back channel. Okay, we wake up, stop looking at emails. And so, what are the top way of giving back channel feedback? The top 4 from looking at data, the top 4, the first one is pause. As a pause, you're more likely to give a back channel feedback. Not too surprising, but that's interesting. Gaze is really important. So if I look back, so if I look back at you, and it was funny in this case because Ed didn't hand out, but he smiled. And you can see the smile came a little bit later, so he realized that he should be giving a handout there. So there's a delay, and there's really a decay over time. And the reason I'm showing this is that we believe that this kind of relationship between speaker features and listener behaviors, there can be a temporal delay, this correlation, or there can also be a decay. So we create this kind of encoding dictionary to really be able to understand how people are behaving. So we can see that pause is important, gaze. The word and, or in general this kind of word, is by itself not really predictive. But if I'm talking and, okay, come on guys. So if I say something and look at someone, that is extremely predictive. I'm kind of requesting, and we're expecting more to the sentence. So definitely these words are important. Engage is also important a second time. And in this case, it's, if I'm not looking at you, you're unlikely to head nod. This would be different for verbal feedback. This was, in this case, a visual feedback. So the rules are different for verbal feedback. A lot of them are similar, but I would say the ideas definitely would be different. Taking this kind of technology, we want to go a step further. And I show you this video of 3 people interacting, all listening to the same speaker. And I told you there's a lot of difference. I want to quantify this difference between people. And I want to explicitly build a model that will learn that difference and take that into consideration when predicting. To do that, what we did is had the same video watched by more than 9 or 10 people, all watching the same video. In this case, it's a proactive watching where you press the keyboard when you think it's a good time to give a nod. We call it parasocial sampling. When you get these prediction, you get this prediction of when is it a good time to give feedback, and we want to be able to learn what are the prototypical way people are behaving. Looking at this, we expanded our earlier work to be able to learn this latent mixture of experts. Why a latent mixture of experts? Because each expert is seen as its own prototypical way of behaving. So you have an expert for person A, an expert for person B, and you have all of these experts, and you're learning this latent, in some sense, this latent structure that really looking at what are the prototypical way people are behaving. Learning this prototypical behavior, we get from our knowledge, this is the best state-of-the-art performance for listener back-channel feedback. And this is what we call wisdom LMDE or NME, which is a latent wisdom-based latent mixture of experts. Using that, we can now look at the latent variable and start analyzing what are the most prototypical features for each of the groups. So you end up, when you do this analysis, with 3 groups. There are certain people who seem to be strongly based on audio features. So probably some of them are not even looking at me right now. So pause and low pitch would be the way to give me feedback. Some people seem to be strongly related to visual. We see gaze, and in this case eyebrows. We also had smile as really strong behaviors. And that would be probably equivalent to, these 2 are probably equivalent to me, si je vous parle en français en ce moment et que vous me hochez la tête, c'est un peu comme purement non-verbal. Donc, don't worry, I will not talk to French too much, but there are a few people who understood, so don't tell people what I said. But definitely these 2 are quite non-verbal, but we also see in a strong group that also syntax really important. In fact, the non-phrases, segmentation of non-phrases seems to be extremely important in this case to be predictive of listener feedback. So, putting all of it together in a real system, I'm going to show this work in collaboration with Stacy Marcella. What we do here is take a movie and only take the audio track, only the audio track and the transcription, or you could do speech recognition. Only using that, I will animate a virtual character. Okay? So the only thing you get is transcript, and you know the characters, so the diarization is there. Let's say we solve a lot of problems, but for the let's go ahead. We have this, and then from that we will animate a virtual character. All of it is automatic. So given that you have the speech and transcription automatically animating, you will see a lot of things happening in the same time. First, you will see speaker gestures. So as I speak, you want to be able to animate the gestures and the facial expression of the virtual character. So I'm predicting from speech, I'm predicting the gesture of the speaker. But what you will also see is from the speaker audio, I'm also going to predict the listener gestures. All of it in the same framework. And so, and you probably recognize A Few Good Men, the movie.
You snotty little bastard. Your Honor, I'd like to ask for a recess. I'd like an answer to your question, Judge.
The court will wait for an answer.
If Lieutenant Kendrick gave an order that Santiago wasn't to be touched, then why did he have to be transferred? Colonel, Lieutenant Lieutenant Kendrick ordered the code red, didn't he? Because that's what you told Lieutenant Kendrick to do.
Object! When you look back, you cut these guys loose! Your Honor, you have Marcus inside the body trans. Your Honor, you doctored the logbook. Captain Mercer, consider yourself in contempt. Colonel Jessup, did you order the code red?
You don't have to answer that question.
I'll answer the question. You want answers? I think I'm entitled. You want answers? I want the truth! You can't handle the truth!
You can see here everything is automatic, but being in Hollywood, we definitely decided of the right angle of the camera. We didn't get that from the speech and the color of the person, but everything else is automatic, both the speaker gesture and the listener gesture. So, to summarize, what I presented to you is this great challenge of human communication dynamic. How can we model behavioral dynamic, multimodal dynamic, interpersonal dynamic, and going in the future, looking at cultural and societal dynamics. I showed you many examples of this about Sim Sensei and the idea of suicide prevention. We've also been working on a system for virtual audience and negotiation. So this is work, I'm going to skip that because of time, but this is work that I believe has a strong impact, and if you're interested to work on this topic, there's a lot of software and data set already available to push forward this agenda. And I believe this is really a great way of bringing together the NLP community, language, and the computer vision community, the HCI, and the machine learning working together. Thank you very much for your attention. Sorry, I talked quite a bit.
All right, we have time for just one or two questions, after which we can take the discussion over to the LTI. Questions?
So I'm surprised that you can do, I don't know how to quantify well or not well. I see that at one point you said you get a score of 0.4. I assume against sort of what happens in truth, against what the system predicts. But it does so on very, very simple features. Right? It has no model of what the person is feeling or what the intention is or anything that's more emotional or psychological. It's all just at the surface, just how they move or the words or the pauses and things. Is there, you said that the remaining 0.6 is all this deeper stuff. Or so, where does that lie?
So there are two things interesting here. First of all, back channel are optional. So Evan, I didn't put it there, but human coder, or if you look at the three people, how much they agree, the agreement is about 0.35. So this is like, in some sense, we're almost as good as human agreement. So we reach human agreement level. That's one thing, because the back channel is by itself optional. But what's really interesting of this is we're really doing shallow prediction. It's really shallow. We're looking at low-level feature, at least in this case, low-level feature. It's really good, I think, to predict the timing of high likelihood of back channel. It's really good at doing that. But to really have the full system, we also want to do inference on like the dialogue intent, infer based on your own goal and beliefs, find out what would you want to animate, and then reconnect with the shallow prediction. So the full system, and I didn't have time to present everything, but the full system, I believe in this high, quick link, this shallow prediction, is complementary to the full understanding. And for some of it, bubble head and all this, shallow prediction is good, but for the more, that's more for the generic feedback. But for the specific feedback, I think you want to go to the full loop. So that's how I see the two together. So yes.
Are you working on a deeper system, or is anybody working, or is that still way, way further than we can do?
We're definitely making progress. The cerebella that I showed has inference, much stronger inference about the content of the words, and try to infer from that using NLU, try to infer some dialogue state. I mean, this is really first version of that. And then from that, try to be able to generate. In the system that we have at ICT, also we have a lot of dialogue management that will infer some of the, based on the belief and the world state, being able to infer what's the action or what is the next action I want to perform, and that will eventually be connected with this. I think there are some work there, but there's a lot more to be done. I think we're at the beginning of that, and there's, I know for sure there's some work here on that same topic. So this is, I think, is a nice hybrid approach, I would say. Shadow prediction has its own place for certain aspects, but I think it works really well when you want to contextualize things. So yes.